Hello everyone, welcome to provide a solution given this nice algebra problem, which is k times k times k, subtract k times k, this is equal to 100. So what is the value of x? Solution here, k times k times k, this is k to power 3, subtract k times k, which is k squared, this is equal to 100. Now we can express 100 basically as 125 subtract 25. So this is the same thing as k to power 3 subtract k squared. This is equal to 125 subtract 25. Okay, so here we will have k to power 3 subtract k squared subtract 125, okay, plus 25. This is equal to 0. Now from what we have here, we have k to power 3 subtract k squared subtract 125 can be expressed as 5 to power 3. So this is 5 to power 3 plus 5 to power 2. This is equal to 0. Now we can rearrange this equation as k to power 3 subtract 5 to power 3 subtract k to power 2 plus 5 to power 2. This is equal to 0. Now, as you can see here, we have k to power 3, subtract 5 to power 3, subtract. Now, this is the same thing as k to power 2, subtract 5 to power 2. This is equal to 0. Now, the first part here, we have two parts. The first part actually is the difference of two cubes expressed as a cubed minus b cubed. And the second part here, this is the difference of two squares expressed as a squared minus b squared. Okay, so let's solve the first part, which is actually a cubed minus b cubed, which we can express as a minus b, a squared plus ab plus b squared. Therefore, k to power 3 subtract 5 to power 3. This is the same thing as k subtract 5, then k squared plus 5k plus 5 squared, which is actually equal to 25. Now, this is the first part. Now, let's solve the second part, which is the difference of two squares expressed as a squared minus b squared, which we can express as a plus b, a minus b. Let's apply this property. So we have k squared minus 5 squared, which we can express as k plus 5, k minus 5. And let's call this one equation 2. So let's combine equation 1 and 2. Okay, so we'll have k subtract 5, k squared plus 5k plus 25, okay, subtract k plus 5 and k minus 5. So this is equal to 0. Now here we have two parts. Let's proceed. Now from this equation, we have k minus 5 into the parentheses k squared plus 5k plus 25, subtract k plus 5, k minus 5. So k minus 5 here is common. Let's factor out k, subtract 5. So we'll have k minus 5 into the parentheses. This is k squared plus 5k plus 25. Subtract, now this is k, and then we have subtract 5. This is equal to 0. Now we have two parts here. The first part is k minus 5. This is equal to 0. Okay, and actually you can call this one k1, which is 5, and this is a real solution. Now we have k squared plus, now here we have 5k, minus k, so this is 4k plus 25 subtract 5, this is 20, which is equal to 0. Now from what we have here, this is a quadratic equation of the form of AK squared plus BK plus C, this is equal to 0. Okay? Now from what we have here, you find that A is equal to 1, B is equal to 4, and C is equal to 20. Okay? So for the value of K2 and K3, we introduce a quadratic formula which is negative B plus or minus the square root of B squared minus 4AC divided by 2A. Now, let's substitute the values of A, B, and C. So we'll have negative 4 plus or minus the square root of B squared, which is 4 squared, subtract 4 times A, which is 1, times C, which is equal to 20, divided by 2 times 1. So here we'll have negative 4 plus or minus the square root of 4 squared, this is 16, subtract 20 times 4, this is actually equal to 80, divided by 2. Now from what we have here, we have that negative 4 plus or minus, now this is the square root of 16, subtract 80, which is actually equal to, now we have 16 subtract 80, which is actually equal to negative 64, divided by 2. Now we have negative 4 plus or minus square root of negative 64, divided by 2, okay? So this is the same thing as negative 4 plus or minus, this is the square root of 64, this is actually equal to 8, and the square root of negative 1, this is I. So this is divided by 2. All right. So now here we have two possible values of K. We have K2 as negative 4 plus 8I divided by 2, or K3, which is essentially negative 4 plus or minus 8I divided by 2. Now, if you simplify here, we will have, this is negative 2 plus 4I, and K3, this is actually, if you simplify, this is negative 2 subtract 4I, okay? So we have negative 4 plus or minus 8I divided by 2. So that means that we have two possible values of K. K2 is equal to negative 4 plus 8I divided by 2. Or K3 is equal to negative 4 subtract 8I divided by 2. So that means that K2 is negative 2 plus 4I. And K3 is negative 2 subtract 4I. Now these are the two complex roots. So that means that we have only one real root, which is K1, which is equal to, this is essentially equal to 5. And this one will give us a real solution. So let's substitute the value of K1 to check if this K1 actually satisfies the equation. Now, if you recall, we entered K multiplying by K multiplying by K, subtract K times K, this is equal to 100. So this is 5, this is the same thing as 5 times 5 times 5, subtract 5 times 5, this is supposed to give us a value of 100. So here 5 times 5, 25 times 5, this is 125, subtract 5 times 5, which is 25, this is equal to 100. So 100 is equal to 100. So the left hand side is equal to the right hand side. And therefore, that affirms that the value of, we have three solutions, one of that being a real solution and the other complex solutions, two of them. So, and these are the solutions to our algebra problem. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye.